Hello everyone. In this lecture, we will discuss the inverse Laplace transforms. Now recalling the first 4 lectures, where we have discussed the Laplace transformations of different functions. Now recalling the Laplace transform, as you know, suppose your L of f of t is f of s. Then immediately we get it reverse. L inverse of f of s is equal to ft. For example, if you are given, L of 1 is 1 by s, immediately you get L inverse of 1 by s is equal to your 1. Likewise, if you are asked what is L of t, here L of t is 1 by s square, and so this implies what is L inverse of 1 by s square, and immediately you say t, right? So let us first see how the inverse Laplace transforms can be obtained directly from the table, right? Inverse Laplace transform reads from table, reads directly from formula table, Already I have told you the Laplace transforms the given function and the Laplace transform. Now suppose you are given f of t, and I come from first f of s, then ft. In the previous table we have seen what is ft, then accordingly what is your fs. Similarly, we read ft out of fs. So it is my fs given, and we have to find what is L inverse of fs. Right, what is L inverse of fs? We have to find. This is nothing but my f of t. Right, as you know, if it is 1 by s, then it is your t. If it is 1 by s square, then it is your t square. If it is factorial n by s to the power n plus 1, right, then it is t to the power n, where you know that n belongs to your n star, positive integer including your 0. E to the power at, then it is your here 1 by s minus a, then it is your e to the power at. Likewise, 1 by s plus a, it is your e to the power minus at. Suppose I say 1 by s minus ln a, it is your a to the power t. Okay, accordingly, if you have omega by s square plus omega square, then it is the inverse is sine omega t, right? Similarly, if it is s by s square plus omega square, then it is cos omega t. Likewise, your hyperbolic function, here omega by s square minus omega square, then it is here sine hyperbolic omega t. If it is s by s square minus omega square, then it is here cos hyperbolic omega t. Likewise, if you recall, what is the Laplace transformation of t sine omega t? We obtained it by using the derivative rule, right? So it was my 2 omega s by s square plus omega square whole square, right? Accordingly, you should recall for t cos omega t, it is s square minus omega square divided by s square plus omega square whole square. It is for your t cos omega t. Accordingly, if it is t sine hyperabolic omega t, it will be 2 omega s, right? 2 omega s by s square minus omega square whole square. Similarly, t cos hyperabolic omega t, it will be here s square plus omega square by s square minus omega square whole square. You may compare this, okay? You may compare this. Where there is plus, where there is, here this is minus and here this is plus. Here plus and here it is minus, right? You see this and this. Clear? Likewise, also let me to remind, however, this 4, okay, t sine omega t, t sine t cos omega t, these are all obtained out of the rule L of TFT. You should recall it. L of TFT is minus d by dsfs, right? You may see it from my third lecture in details, right? And these are all because of this. These are all because of this. But if you remember this as formula, it will easy to work out the problems in competitive examinations. Okay. So at this juncture, let me to remind you also what is the Laplace transformation of root over of t, you know, right? Already you got it. If it is t to the power half, it is t to the power half, then it will be here root over of pi divided by 2s to the power 3 by 2, right? And here t to the power minus half, it is here pi by s root over, pi by s root over, right? You may see, you may recall here this thing from my lecture 1. You may recall it from my lecture 1, okay, from my lecture 1. Clear? So the first aspect is you read directly from the formula table. Read directly from the formula table. Now coming to the second aspect of finding the Laplace inverse here. Second aspect of finding the Laplace inverse here. Right. The second aspect is to find the inverse Laplace transform with little adjustment. With a little adjustment, he said. Little adjustment. Suppose I ask you, what is L inverse of? For example, suppose I ask you, what is L inverse of 1 by s square plus 3, right? 1 by s square plus 3. If you recall your sine omega t, here we need omega by, right? So here omega in the denominator is 3 here. Omega is 3 here. So we need L inverse of 3 by s square plus 3. So to get it adjusted, right, we divide a 3 here. Now we are ready to apply the formula. It is 1 by 3 sine 3t. Okay, sine 3t. So with a little adjustment here, we get it. Suppose you are asked, what is L inverse of 1 by s to the power n plus 1, right? 1 by s to the power n minus 1. We recall the table Laplace transformation of t to the power n. We recall it. You recall it. Clear? T to the power n. So for adjustment, we need n factorial to be multiplied here, right? So this will be, for the sake of the adjustment, we need here L inverse of factorial n by s to the power n plus 1, right? Accordingly, we need to divide the factorial n here, right? Of course here n is a positive integer, you say. So this is equal to factorial 1 by factorial n, and it is here t to the power n, right? So we can directly read from the formula table, however with a little bits of adjustment. Now coming to the third aspect here. The third aspect is, the Laplace transformation is a linear operator, right? linearity property you apply. Linearity property. As you know, Laplace inverse of suppose some fs constant times fs plus some constant times gs. It may be plus or minus, no issue. That means separately you can read it, the Laplace inverse by taking the constant outside. So this is k1 L inverse of fs, and it is plus or minus whatever it may be. It is k2 L inverse of gs, right? So we apply the linearity property to find the inverse Laplace transforms. I am solving so many solved examples, right? So that it will easy to work out the problems, right? Suppose I ask you to find what is the L inverse of 1 by s plus 2 plus 3 by s square plus 25 plus some s by s plus some 7s by s square minus 9. In this way you are given and you are asked to find what is the inverse Laplace transformation of this function, right? So we will split them. We'll split them. So this is L inverse of 1 by s plus 2 plus 3 taken out. It is L inverse of 1 by s square plus 5 square and plus 7 taken out. It is L inverse of s by s square minus 3 square, right? Now you recall the formula. You just see the formula table, right? This will directly read. It is here e to the power minus 2t, and here a little bit of adjustment is needed. Omega is here, so we need to multiply 5 here, and you need to divide a 5 here, right? Then it is here 3 by 5. It is the Laplace transformation of what? It is sine of 5t, right? Sine of 5t. Now it is here plus 7, and it is directly s by means cos hyperbolic 3t. Okay, so accordingly you apply the linearity property. Now once you are expertised, no need to, you can omit the second step, you directly read it from the first step. Okay, so now coming to the third aspect, you apply this fast shifting theorem, right? Then the fourth aspect is to get the inverse by applying the fast shifting theorem. Shifting theorem. You can recall the fast shifting theorem from our lecture 3. If you recall, what is the fast shifting theorem? If L of ft is equal to fs, right, then L of e to the power at ft is equal to f of s minus a. So accordingly here I shall write if L inverse of fs is equal to ft, right? L inverse of fs is equal to ft, then L inverse of f of s minus a will be e to the power at ft. Similarly, L inverse of f of s plus a, right? It is e to the power minus at ft, isn't it? And here similarly, what is here? L of e to the power minus at ft. This is here f of s plus a. Okay, so now we are going to use this thing to solve the inverse Laplace transform. In fact, it is important in many aspects. Coming to certain examples, if I ask you find the Laplace inverse of if f of s is equal to, say, some 1 by s square plus some 6s plus some 10, right? And you are asked to find what is f of t. right? So you need to apply the inverse transformation here. You see the denominator here it is cannot be factorized, right? If it is factorized, then you can apply your partial fractions. So now we'll adjust it, right? We'll adjust it. So what is my ft? My ft is L inverse of this fs, means 1 by, I can write it s plus 3 whole square, means s square plus 6s plus 9, it remains with your 1, it remains with your 1, right? So I just I adjust it. Clear? Now you see, you forget about this s plus 3, right? For this plus 3, for this plus 3, you can write it e to the power minus 3t, right? E to the power minus 3t. You see this. Now it is in the form of 1 by s square plus omega square. Then it will be here simply sine omega t, right? Suppose, coming to another example, if you are asked to find, you find the L inverse of s by s square plus 6s plus 10. Then what to do, right? You need to adjust it. The denominator is s plus 3 whole square plus 1, right? So since here it is s plus 3, we need s plus 3 here, s plus 3, and accordingly we need to subtract minus 3. So this is my L inverse of this, So I separate them out, right? So this is equal to, you will able to write it them. So this will be L inverse of s plus 3 divided by s plus 3 square plus 1 square, then minus 3 taken out, it is L inverse of 1 by s plus 3 square plus 1, right? So accordingly you now apply the shifting theorem here. So here it is e to the power minus 3t. Now you think it is s by s square plus 1 square, it is simply cos t, and the next one will be 3, this e to the power minus 3t, it is here sin t, right? In this way you can, so here it is sin t only, not omega, it is simply sin t only. Okay, so here similarly, suppose you are given one more example. Suppose you are asked to find what is the inverse transformation of 1 by s square plus s plus 1, say, right? Then you adjust it. You can write it L inverse of 1 by s square plus, you write it 2 into s into half plus 1 by 2 square, right? Make it perfect square. Then you adjust it, 1 minus, this is being extra, 1 minus 4, is not it? So now this will be my L inverse of 1 by, this is s plus half whole square, and it is 4 minus 1, 3 by 4. So this is plus 4 minus 1, 3, means I can write it root over of 3 by 2 square. Okay, now it is of the form of omega by s square plus omega square. So I can write it, right? I need a root over of 3 by 2 in the numerator. So in the denominator, so I need to write 2 by root over 3 taking outside here. So this is s plus half square plus root 3 by 2 square, right? So now you directly read it, omega by s square plus omega square. Now this plus half will be, so this is 2 by root over of 3. It is because of this plus half, it is e to the power minus half t, right? It is sine root over of 3 by 2 root over of 3 by 2t. Okay, so this is your answer. So these are the several examples to apply the fast shifting theorem to get the inverse, right? Now these several examples will help you to easily solve many problems of several varieties. Now coming to the next aspect, use of derivative, right? You know how using the derivative rule already I have told you. So this is now coming to my fifth aspect. My fifth aspect is the use of derivatives, right? Use of your derivative. Use of derivative. If you recall, already I have told you in the formula table, t sin omega t like that, right? You know, L of TFT is what? L of TFT is minus d by ds fs, right? You should use it. L of t to the power n ft. If t to the power n is multiplied, you just recall it is minus 1 to the power n. Nth derivative of fs, right? So, for example, if you solve some example, you find, suppose your f of s is equal to ln s plus a by s plus b, and find, it is asked to find what is your f of t, right? What is your f of t? You see, now your f of s is ln s plus a by s plus b. So you can write it ln a by b, ln a minus ln b, ln s plus a minus ln s plus b. Now it is easy to differentiate it. So you differentiate the left hand side and right hand side. You keep in your mind minus d by ds of fs. So what is my d by ds of fs? Right. If you differentiate the right hand side, so it will be 1 by s plus a, and it will be minus 1 by s plus b. Okay. So now as your formula we need it minus here. So we make it minus. We make it plus. So now the left hand side becomes what? It is your L of TFT. It is your L of TFT. So it is by 1 by s plus b minus 1 by s plus a. So this implies, what is your TFT? Your TFT is equal to L inverse of 1 by s plus b minus 1 by s plus a. So this will be equal to here. This will be equal to e to the power minus bt minus e to the power minus at. Now divide this t here. So this implies your ft is equal to e to the power minus bt minus e to the power minus at divided by your t. It is your answer, right? Likewise, if I ask you one more example, right? Suppose you are asked to find L inverse of arc tan s by a, suppose, right? So this is my arc tan, means cot inverse of s by a. You are asked to find the inverse. Then same thing, it is easy to get the differentiation of tan inverse s by a, cot inverse s by a. So my let fs is equal to my cot inverse of s by a. So you differentiate both sides. So this implies my d by ds of fs. You know, it is tan inverse x is 1 by 1 plus x square. So here it is cot is minus 1 by 1 plus s square by s square, and you apply the chain here again. Because of the chain rule, derivative of s by a is 1 by a, right? If you, now we need a negative sign here. So we make it plus here, right? So now the left hand side is my L of TFT, and is my right hand side is my, simplify it, it will a by simply s square plus s square, right? A by simply s square plus. So what is my TFT? My TFT will be L inverse of A by S square plus S square, omega by S square plus omega square. It is equal to my sin 80, right? It is equal to my sin 80. So what is your FT now? So FT is here sin 80 divided by T, right? Divided by T. Okay. Then you come to the next aspect, sixth, use of integration, right? My sixth aspect is use of integration. Use of integration. You recall now, if t is divided, right, then you recall L of ft by t is integral s to infinity fs ds. You recall it, fs ds, right? So suppose you are given some examples. You find L inverse of, you have to find what is the L inverse of 2s plus 6 divided by s square plus 6s plus 10 whole square. Suppose you are given like this, right? Then how to solve it? How to solve it? You see now. Now it is easy to integrate. If I substitute, this is my, the denominator is my some p here. If I substitute, say this denominator is my p here, then it will my dp by p square, is not it? So let my fs is equal to 2s plus 6 by s square plus 6s plus 10 whole square, right? Now if we put the denominator is p, so it is of the form of my dp by my p square. It will take this form, is not it? If I put this is here p, then 2s plus 6 ds, right? So what is my integral s to infinity fs ds? So this will my integral s to infinity this ds, right? Now the moment I am putting this, so it will be of this form, right? So what is the integration of dp by p? It is here minus 1 by p, is not it? So that means my minus of 1 by what is your p? S square plus 6s plus here 10 from s to infinity, right? From s to infinity. This s to infinity intact here. So that is equal to, right? If we put infinity, it is here 0. If we put 0, it will s, then it remains same, s square plus 6s plus 10. Clear? So that is equal to here 1 by s square plus 6s plus 10. So what happens to your left hand side? So your left hand side is nothing but L of ft by t, L of ft by t, right? So that is equal to, already I have told you, you write it 1 by s plus 3 whole square plus here 1, is not it? Then what is your ft by t? Your ft by t is equal to L inverse of 1 by s plus 3 whole square plus 1. So this is equal to e to the power minus 3t sin t. Now this t is multiplied here. So therefore what is your ft? So what is your ft? Ft is t e to the power minus 3t sin t. Clear? So this is your answer. The video is getting lengthy, so just I will tell you one more aspect. So that is if t is divided, then it is integration. Similarly, if division of s, now it is the seventh aspect, right? The seventh aspect to find the inverse is the division of s. Division of s, right? One formula I will tell you here. L of integral 0 to t ft dt is here 1 by s fs, right? If s is divided here with fs, then you find the inverse Laplace transform. For example, suppose you are asked to find what is L inverse of 1 by s into 1 by suppose you are s plus 1 say, right? Though you know other aspect a by s plus b by s plus 1, but I think this is my f of s now. Now from this f of s, what is my f of t? It is e to the power minus t simply. Now because of this 1 by s, I am going to integrate it from 0 to t, is not it? I simply integrate it from 0 to 2. So this will be my, what is the integral now? E to the power minus t is minus e to the power minus t from the limit, it is 0 to t. So if you apply it, it is my e to the power minus t, it is my minus 1. So this is 1 minus e to the power minus t. If coming to one more example, so it what is the L inverse of 1 by s into s square into s plus 1, right? Suppose it is asked, means you need to integrate it twice, right? For one s, as you did earlier, integral 0 to t. Again for another s, it is integral 0 to t, and from this the Laplace transformation here is inverse is e to the power minus t, okay? And you integrate it, here. So already as we did it, so this is integral 0 to t, it is here 1 minus e to the power minus t. You just integrate it again, right? So it will give you 1, the integration of t is 1, plus it becomes here e to the power minus t by minus 1, right? You apply the limit again from 0 to t. Substituting t, it remains same, t plus e to the power minus t minus here second limit, it is 0 and it is here minus 1. So this is your answer. Clear? Of course the other way I will tell you later on. You can find it. It is a by s plus b by s square plus c by s plus 1. It is because of your partial fraction. It is because of your partial fraction, right? Partial fraction. If you solve it, you will get a will be here minus 1. You will get b will be here 1, and you will get c will be here 1, right? And your fs will be of this form by applying the partial fraction rule. Now if the moment you find ft, it is L inverse of this, L inverse of 1 by s is 1, so it is a is minus 1, and it is b is here 1, so it will give you t, and c is here 1, it will give you minus t, right? So this is partial fraction. So the another way of getting this. So in the next lecture I will tell you, right? In the next lecture I will tell you how to find the Laplace inverse by using Laplace transform, right? By using inverse Laplace transforms. So the video is getting lengthy. Let us close here. Thank you all.